So fuel, last time we left off, we finished up measurement, automatic level measurement. When our automatic system isn't working, we have a backup system that can be used on the ground to get an initial fuel level. So a ground crew would get an initial fuel level, and then the crew would monitor fuel flow in flight to essentially subtract from that. And based on, they know with these aircraft, they know pretty well what the average burn per hour is at a given power setting. Plus you have fuel flow meters and gauges and fuel used gauges that track your fuel flow in the flight deck. And so if you have a starting amount of fuel, you can get a final amount. Now, remember, we're looking at fuel in pounds or kilograms. And I've explained it, I know, in the lab to a couple people, but who knows why we use pounds or kilograms instead of a volumetric measurement? Because what can change? A volume of a given amount of fluid can change based on temperature because its density changes. So why is pounds, why do we use that though? Why is that important? The weight's the same. Weight is directly correlated to the number of molecules of fuel you have, and each molecule of fuel has a certain amount of energy it contains. So by knowing weight, we know how much energy we have available. With a volume, that can fluctuate. Small aircraft, it's not a big deal. There's not a ton of change there because their tanks are small, the percentage of change is small. But on a large aircraft, it can make a fairly big difference. So if we don't have a system that can automatically do that, we got to go through a few steps to figure it out. So here's an example. This is what you would see on the outside of the plane and what the inside of this panel looks like of a magnetic level indicator. Now in your lab, you use drip sticks. Most new aircraft don't use drip sticks anymore. So what we have is this stick right here has a magnet at the end, this little white tip, and then you have a float that also has a ring, has a magnet inside of it. And so that float normally sits on the surface of the fuel. And what we do is we unlock this little locking mechanism at the bottom, so like a quarter turn counterclockwise, bring it down. And as we pull it down, when the top of the stick gets to that float, that magnet will engage and we'll feel that resistance of that float. We'll be able to feel it trying to pull down on the float. And so then we set it where that float's right at the fuel level. Okay, at the top of the fuel. So it looks something like this. So here's it stored on the right, and then we pull the stick down until it catches the float magnet, and then we can see it's graduated. It tells us how much fuel is above this bottom surface of the wing. Why is our float on a magnet? Why isn't it just fixed to the end of the rod there? Seems more complicated than it needs to be. Why do you think we wouldn't just, why not just have the float on the end of the rod? And then when you just pull it down, you feel when the float hits the fuel. It's not hollow. These aren't hollow. You're thinking of the drip stick, which is like a straw we bring down. You bring down until it starts to drip fuel out. That's old school style. Keep it up and down, okay? Is this float, is the level of the fuel always at the top of the rod? These are skinny fiberglass rods, and then you got this big float right here. What would happen to the rod if there was a big weight on the end of it? It'd constantly be sitting there going like this inside the tank, right? So that having that float down, it keeps it so that it's not sitting there bending that rod back and forth all the time. So we pull it down till it hits the top of the fuel, we can feel it, and then we can measure how many inches there are, and it's reversed, so you can see here it's 12 and 11. That tells you the top of the stick is if here it's about 12 and a half, right? And you read it typically to the bottom of the wing plank or the bottom surface. So right here, if that's where the float engaged, you would have about 12 and a half inches of fuel to the top of the rod. Okay. Again, that gives us a volume, not a, well, it doesn't even give us a volume, it gives us a height, right? So we need to convert that. We got to do a couple conversion steps. The first thing we got to figure out is that height of fuel will depend on how the airplane's sitting. All right, so these sticks are go along the bottom of the wing. I have 3 or 4 of them along my wing. And if I'm tilted more one way or the other, that's going to affect where the where the fuel is sloshed around in that wing. So we have to know the pitch and roll of the aircraft, and this is done somewhere on the airplane. On this one, it happens to be in a wheel well. Some aircraft is back in the tail. There's going to be a plate like this, a graduated plate that shows pitch forward and aft, positive, negative. It shows wing roll, and then above it, there's a spot to hang a plumb bob. So here's the plate right here. And up top, we have our plumb bob tied, and we hang it down. And we look at what the tip of that plumb bob is pointing at on that chart, on that grid. And it tells us how many degrees, nose high or nose low, or how many degrees roll left or right the airplane is sitting at. And then we can take that and we have a table based on that. So like here, they're all for, I think these were out of the 757. I can't remember what airplane, doesn't matter. But you have like this table right here is if your pitch is between 0.75 to 1.5 degrees and your roll is 0 to 0.25. So on this version, they call, one wing is negative roll, one wing's positive roll. So depending on which indicator, there are different indicators throughout. You want to use the one furthest outboard that indicates fuel. But as the fuel level in the wing drops, you may not be able to use the furthest outboard. So if we have my wing, wonderful wing. There's my wing, right? It's a really bad wing, but. And, if my fuel level is sitting right here, I might have, whatever green is going to show. Nope, I can tell it didn't show. If I have, say, 4 sticks in here, or you can see if I were to use that most outboard stick, I wouldn't get any kind of a level indication. But, and they would typically call these number 1, 2, 3, and 4, 4 being close to the wingtip, 1 being close to the root. So I would use stick number 3 in this case. I would drop it down until the top is even with the fuel. It's got a little float here. Little floats. This little float sitting on the bottom. And now my stick would be hanging down, and there'd be a certain number of inches that we would be able to read it hanging down. Okay. And so in this case, if I did, tank number or indicator 3, and let's say it was hanging down 6 inches, and with the pitch, say we were at a degree pitch and a 0 roll, 6 inches down, we would have 1,352 gallons in that wing. You can see here, this one's negative 0.5 to 0 and roll 0.25 to 1. So you'll have a whole bunch of these different tables, combinations of various pitches and rolls. So you have to look up the correct table based on what you got on your chart, right, or on your grid right here with the plumb bob. Okay, you can see here's the stick down, and I'm just showing it different configurations. Okay. But again, that still gives us a volume, not a weight. Thank you. So what do we do to get weight? What do we have to do? Now we have a volume of fuel. So first we started out with a distance fuel was from the bottom of the wing. And then we figured out what the volume was. We converted it to a volume. What do we have to do to convert it from a volume to a weight? What do we have to know? Temperature. So I'll give you, it can't just be temperature because it could depend on if you have Jet A1, if Prist was added or not. Density. You need to know the actual density of fuel. All those things, temperature, but also does it have Prist mixed in it or not? Prist is for winter operations. It's an anti-icing agent. Is it Jet A? Is it Jet A1? Is it some other fuel? What kind of additive, there's different additives added to jet fuel by different refineries that can slightly change the density. So since we don't know we can't know the density just by knowing about what kind of fuel is in there, we have to measure it. What do we use to measure density of a liquid? A hygrometer. Okay. Who remembers Where'd you see a hygrometer? Not in the camp. You can't be in the lab where I talked about this already. Who knows where you saw a hygrometer? What class did you guys use a hygrometer in, guys and gals? A what? Electrical to do what? You test battery acid with a hygrometer. You check your acid to water mix, okay, ratio, because that density changes. This is not the same hygrometer. You have a hygrometer for fuel. It's got a different calibration scale on it than the hygrometer that you used for batteries, but it's the same type of tool. You fill the little vial with fluid. You put the little floaty stick thing in it, and you measure where it, where it floats at to tell you what the density of the fuel is. Right? You got the stick with the float on the bottom that moves up and then everyone remembers what it looks like. So then you can take, it'll give you pounds per gallon or kilograms per liter, depending on whether you're operating your aircraft. You can multiply those gallons there that we have by that density per gallon or density per liter, and that will give us a pounds of fuel that are on the aircraft. Okay?